All right, hi everyone. I'm Brooke, and I have some slides prepared. We have about an hour, which is not a ton of time to introduce an entire language and ecosystem, but I'll do my best. So I'm just going to get this going, and I've never actually tried to screen share a keynote presentation before, so I'm going to try it in the full thing. Otherwise, we might just have to look at literally the slides. I guess probably the entire desktop will work. Okay, can everyone see that?
Yep.
Yes.
Excellent, great. So yes, this is going to be a whirlwind tour of Elixir. So a little bit of background first. So who am I? I am the co-founder of a company called Fission. We're building Web3 tools for the Web 2.0 world. So Web3 is all of this blockchain and IPFS and distributed systems stuff. And trying to make that easier and make things like deployments easier, not need containers, going one step past serverless. If anyone wants to play with the early access on that, tools.fission.codes. I'm a programming language theorist and virtual machine enthusiast. I'm also an Ethereum core developer. Ethereum is a blockchain project, though I'm getting less involved in that now. And previously, I did a few years full-time as an Elixir dev. I've written a bunch of libraries, did some keynotes. I did the keynote for ElixirConf this year, that's that photo. But I'm mostly known for two projects. One's called Exceptional, which is for error handling, and the other one is Witchcraft, which brings a lot of things from the Haskell style programming into Elixir. Both sort of like the simple functional programming stuff that I would otherwise expect to be there from, Clojure, Haskell, Racket, etc. That wasn't there. And then also bringing in some of these more mathy concepts. So yeah, so it says previously a full-time Elixir developer there. It probably comes as no surprise that I mostly work in Haskell now, given that I've written those libraries. So goals for this talk, I really just want to situate Elixir, give you the main concepts, a little bit of the syntax, just sort of in passing, but mainly concepts. And then we're going to briefly touch on Phoenix, which is the web framework, or the main one at least. So why should people care about Elixir? This is just pulled from the Stack Overflow survey from this year. It's listed as both one of the languages that has the highest rates of open source contribution and with the highest salaries, and Rust is also in both of those too. And before we dive in, a quick backgrounder on functional programming, and just kind of from a historical perspective, because functional programming and imperative programming came about the same time. There's these two mathematicians, Alan Turing and Alonzo Church, and they were both working on a particular problem called the decidability problem. And Church published a paper, and about a week later, Alan Turing published his, in which he describes essentially something similar to what we would consider a computer. They solved the same problem. They've been shown to be totally equivalent, but they have a very different view on the world. So one side is imperative instructions. You'll do these steps in this order. Church's side was, it's all about expressions and these analytic truths. It's mathematics, right? It's just, we make a statement and that's how it is, right? Period. For the imperative side, it's all about global state and memory, right? I'm going to update these variables and everything's going to be in memory. Church's side is about everything's being passed around manually as arguments to other functions. So there's no sense of a global state. And finally, Turing machines are this mechanistic view of the world. They're almost like a clockwork mechanism. And again, Church is more about building this model of how things would be and then passing it arguments and letting it run. A lot of people kind of question whether or not Elixir is a functional programming language because it kind of sits in between these two sides of the spectrum. You can just make mutable changes to global memory. In fact, global memory is a very important part of it, but it also has this sort of analytical truth side where you're doing a lot of pattern matching, you're passing out arguments explicitly, you're passing functions around inside the virtual machine. So it's a little bit of a blend of the two, and it has a very pragmatic focus, which we'll talk about for most of the rest of the talk. So Erlang and Elixir, you may have heard of Erlang, and these two are very related. Erlang came first, and Elixir runs on the same virtual machine. So as you can imagine, Erlang's pretty important to the whole ecosystem. Just a single slide on that. Why is it called Erlang? It's a pun between Ericsson Language, so the big telecom company, does all the network switches and things like that, and a mathematician whose last name was Erlang as well. And they built this in the 80s to the language and the virtual machine, the whole system, to run their high performance telecom switches where you have a single machine that's running, I don't know, let's call it 500,000 connected concurrent phone calls. And if one call drops, you don't want everyone's call to drop. You want just that one call to drop and then the person to dial back in. So that was kind of really the focus, and had to be concurrent and fast and have all these nice properties. It has this kind of weird syntax, which is based on a language called Prolog that very few people are familiar with. So it didn't get a ton of adoption outside of big telecom companies. Has the same virtual machine as Elixir, or Elixir has the same virtual machine as Erlang, I guess you could say. So they're fully interoperable. Any existing Erlang code is usable in Elixir and vice versa. And it also has this actor model, which we have an entire section on later, but they really introduced that into mainstream languages. It existed prior. They didn't even really know that they had reinvented it, but it ended up being a very powerful way of handling concurrency. Elixir, at a high level. So it's fairly new. It was released in 2011, the original first version, which at the time was just a syntax pre-compiler down into Erlang. Now it's been rewritten from the ground up. Has the benevolent dictator for life, Jose Valim, and a merry band of other developers who are primarily from the Rails core team, looking for something that was more concurrent, a little bit faster, and had a little bit more modern features. So they kind of wanted to clean up the whole ecosystem and solve some of the pains that they were feeling in Ruby. Interoperable with Erlang and concurrent fault tolerance. If your code breaks, and we'll again talk about this later, if your code breaks, that's actually okay. And it will just restart that bit of code. It won't take down the entire application. Again, designed for running big telecom systems. And this little bit of code here is the same code as the Erlang, just rewritten in Elixir. It's a lot more familiar, comfortable for programmers in 2019. The philosophy, sort of in short, is to be modern, friendly, readable, a lot of emphasis on developer experience. It's soft real-time, so it doesn't have hard real-time guarantees like you'd need when building, something for NASA. It has soft real-time, which is good enough for telecom. Which say, there's a bit of drift if something doesn't come in exactly a certain number of, nanoseconds after another. It's okay, but it is really designed for real-time work. And it's extensible. So it has metaprogramming, this thing called macros that we're not really going to talk about, but that lets you write language features that you feel are missing in the language, and then release those as a library, and then everyone else can have that syntax. Because they're all from the Ruby or Rails core team, it looks a lot like Ruby, to the point that it's mostly has interest from Rubyists, some functional programming people too, and closurists, but mostly Rubyists have an interest because they think, oh, it's just a faster Ruby. It's not. It feels completely different. It has some superficial aesthetics that are similar and a similar philosophy, but that's it. Ruby, like, it's not an object-oriented language. You just have functions. Concept of an object does not exist. And it's used in a lot of places. Really, any big company that has networking needs, you know, Facebook, Amazon, Google, right? They all have it somewhere in there. If you've ever used RabbitMQ, that's also running Erlang, but, you know, same system. If you ever use Discord, the Slack-like thing, mainly aimed at gaming, also Elixir underneath. And there's even hardware running with it. So Parallella created a hardware board, like a chip, that is natively programmed in Erlang and Elixir. And there's a project called Nerves that makes it much easier to do hardware programming directly in Elixir, but with like directly on embedded systems, which is kind of interesting too. And to just really keep, you know, hitting home with the why you'd be interested in this. Really, the big one that people are interested in is concurrency and fault tolerance. So 9 nines of uptime is sort of the, you know, the constant cry in the space. So that's 99% and 7 other nines after that of uptime. That's 32 milliseconds of total downtime a year for a system that they're at least that they're aiming for. So if you're, you know, tinkering around at home, you probably won't get quite that, but a number of companies have achieved this milestone. So a lot of people say, you know, we have an SLA with like 3 nines. Well, we have 9. So it's really designed for these big telecom systems underneath. Another kind of cool one that most people don't really use as much because it's a bit of a hassle to set up, but you can do hot code reloading. So you can have your server running online and have literally a 0 downtime deploy. No round robin, nothing. It just runs. So let's actually look at some code. So this is a simple module with one function in it that does sort of like a fallback division by 0. So if you try to divide by 0 in this case, you'll get back just 0. And there's a couple sort of strange things in here. The function is defined twice, and one of them has a value in it. And how this works is it works from top to bottom and tries to pattern match. So it says, if my second argument is 0, just return 0. Otherwise, actually do the division. Right? And you can do all kinds of stuff. You can do different types. You can say if this is a list or an integer, or even deconstruct. You know, if you have some sort of container type, you can deconstruct it right in there and pull values out, or say if it has this key but not that key, but all as pattern matching, which is very, very powerful and very declarative. So you're not spending a lot of time going in and saying, get this key out of the thing, check it against this. You're just saying, if I have one of these, do that. If I have one of these, do this. Functions can also take different numbers of arguments. It's called a variadic function. So again, this all has the same name, add, but the first one takes no arguments and just returns 10. And then we can successively add more numbers as we go down. At the bottom one on add 3, those 2 backslashes mean that this is a default value of 10, but that you can override that. So we have both this multiple function heads for a single arity, for a single number of functions, and can have a different number of arguments. Pipes are used pretty much everywhere as well. So the bottom function, this integer.floordiv, you know, and all of the brackets, is how you would write something without pipes, or in, say, in JavaScript, you'd write something possibly like this, or at least you'd be binding them to variables along the side and then threading them through. Pipes get sort of all of that threading and just says, take 1, 2, 3, 4, 5, then stick it into integer.digits, take the result of that into enum.count, and then into floordiv. Right? So that conceptually here, there's this idea that you have a subject getting piped through a bunch of different things being transformed at each step, and this is a kind of function composition. And we also have kind of abstraction. Well, there's two kinds, I'm only going to talk about one, and these are called protocols. So here we have a function concat, and just the number of arguments it takes and nothing about its implementation, which we're going to fill in on the next slide. The other thing I want to point out here is this @doc directive. That's the documentation for this function. And in the command line REPL, you can ask for the documentation on a particular function and it'll give you back that line, and also the documentation generator, which has maybe the nicest docs I've seen in any ecosystem, also takes that and uses that as the documentation there too, which is quite nice. So we have this thing called a semigroup, which really just means you take two things and stick them together. So I have, say, two numbers and I stick them together and I get back another number, and I can always keep sticking more numbers together. You can also do that with concatenating strings or appending arrays together, you know, all of these sorts of things. So def protocol at the top says concat, takes two arguments. We can also go a little further and specify how the types would work, but we're not talking about types right now. Then I say a semigroup for integer is addition. A semigroup for list is concatenation. A semigroup for bit strings is string concatenation, right? And now if I call concat anywhere, it will look at the value of the first argument and then use that implementation of the function. So now we can write functions that don't have to worry about the specific kind of thing or do a type of check everywhere. We just write something that concats things that are concatable. Concurrency, which is really the main reason for its existence, is very lightweight threads, right? So we have green threads. They're virtual, so they're not system threads, which makes them more lightweight than what you'll get in a lot of other languages, like even faster than ones you'd find in Rust, because it's just a pointer in the virtual machine's memory. It doesn't have to actually do anything on the system, right? So you can spin up and down millions of processes very easily. Oh, there's a thing in the chat. Oh,
sorry, Brooke. I was just saying hi, Bethany, to Corel's daughter. It's great that, yeah, she's learning Elixir young.
Yes.
Yay! Cool.
Yeah.
Sorry about that.
Please stay, Bethany. Oh, sorry. Sorry, Brooke. Carry on.
Okay, awesome. Threads. Okay. Yeah, you can spin up millions of threads very easily, even on a laptop, which I have a little pre-recorded demo of that. And there's a function spawn, which is essentially a forking process. And there's a whole bunch of helpers around that. And it's not just, fire and forget. You can also get a reference back to that process. So this example is all of the book War and Peace, counting all of the words, how frequently they appear. We spawn a bunch of processes. They each take a chunk of the book, count up the number of words, and increment a global counter that we've set up. Because these are all running on different processes, this is just running on my laptop. But if it was a really big process, we could have this as a cluster of different systems that each have their own processes, distributed over geography, et cetera. But this is how it actually runs. The thing on the left is showing all the different threads actually running. And when I ran the word counter, the concurrent word counter, it has that little reference there, the process ID as well. And then this is the actual word count. So there's that spike there where the 4 cores on my machine equally automatically load balanced themselves and said, cool, we'll take it in these chunks, even though we're splitting it up. And I think it's 100 lines per task. The 4 cores are able to handle that evenly. And this is just on my laptop. You can do much more on a server. I think I've maxed out at a couple million processes concurrently, but really all this task is doing is spawning a bunch of processes, sleeping those threads for a random amount of time, up to 5 seconds, and then letting them finish. And they print at the beginning and they print at the end. So this is, I think it's 110,000 processes, I think, just on my laptop. And it takes a little bit longer there because of the sleep in it. But again, you can see it, they're handling it equivalently. That first spike is doing the scheduling and the actual dividing up of the tasks. And then after that, it's just them running and taking care of the actual work. And that's about, I guess, 20 or so percent of my machine to do 100,000 tasks concurrently. And this is the actual code. So I'm saying, because I want them to spawn faster than just one after another. So we do 100, and then each of those 100 spawns 1,000. So we get 100,000, and then they sleep for a random amount of time. As you can see with the pipes there, it's one of these values in milliseconds. You can take a random one, sleep for that amount of time, and then print the finish. The actor model, which is another part of concurrency, and it's also, if you dig back to the original object-oriented proposals, they're actually talking about something closer to this than what we actually got. So it's the main takeaway that a lot of people take from Erlang and Elixir and try to apply to especially distributed systems, right? Elixir is fundamentally a distributed systems language. So if you have microservices, that sort of thing, the actor model, and even thinking about it as the actor model can be really helpful, even though you're sort of ruling your own at that point. So we'll do it as a little story to illustrate how the different pieces work. So we have a scientist here who has access to some state. No one else can access the state, just that actor, right? Scientist guy. And needs to get some information from, from actually out in the field, up on the space station. And she has some data as well that only she can access, that she's, working on and adding to all the time. But there's no, direct way of communicating. You can't just go over and, grab the value. You have to actually send a message across. Now, the one out in the field might be busy right now, doing something else, handling other requests. In the story example, out on a spacewalk. So she has a little mailbox that takes all of these different messages and inquiries. Finishes up whatever she's doing, starts going through the messages, and finally gets to the request that we're interested in, gathers up the data, sticks it in the message, and sends it over to another service to just clean up the data, right? So the one collecting the data doesn't have to be the one to know how to present it, per se. So this is just a little presenter service or actor that has no state of its own. It just takes things in, changes it, sends it back out again, and sends it out to the end. That actor, again, might be busy, so it has a mailbox as well. Unlike object-oriented programming, where it's back and forth every time, you can do that. You could turn one of these arrows around and say, here's my reply, and follow the whole path back, but you don't have to. The initial requester can say, this is where I am, this is my address, right, my process ID, and send that along and say, I'm just going to fire and forget, and I'll get the result back at some point. The other thing that's different from object-oriented programming is when you invoke a method on an object, it happens immediately, and it doesn't have the option to ignore it, right? So things are ending up in this mailbox, but then it's the actor's job to decide when to pull things out of the mailbox and whether or not to even look at them at all. They could just say, flush the mailbox, I'm done with this, I'm overloaded right now, don't worry about it. It's more important for me to lose some messages, but keep the system up. Right? It's fundamentally, from an engineering perspective, that might be the best thing to do in some cases. So what can an actor do? It has access to states, or it may or may not have access to its own state that only it sees, and a mailbox. It can send messages to other actors and receive them. It can produce more actors with some initial values as well, and it can decide to read or ignore messages, or even re-queue them if it needs to. Mailboxes are exactly what they sound like, right? We just have a series of messages in a buffer, not your buffer, a message queue buffer. The entire system is asynchronous. So this is really important because you might be getting a lot of messages into one part of the system, queuing them up, and then spawning a bunch of actors to handle them as literally load balancing within your application, right? This is what that looks like outside of code, just in the REPL. So this receive do block says, if I get a message that says cool, and then some value, just take the value. Otherwise, if I get this more nested structure, then if it's, and it's greater than 2, then give me that value back. And it'll try these in sequence from top to bottom. And it'll time out after 5 seconds, right? So it'll remove messages from the queue every 5 seconds as they come in. Supervision is how we get fault tolerance. It used to be, I think, fairly unique to this ecosystem, but other languages have started to catch on and are now doing this too. So Scala has this with the library called Akka. Haskell has Cloud Haskell. There's a whole bunch. And obviously Docker does some of this now too. The philosophy is let it crash, right? So if you have some edge case in your system, it's okay if it just fails, right? You don't need to do totally defensive programming all the time. This doesn't mean that you don't have to handle errors at all, right? Your known errors you should handle, right? I might not get something back from the database. You should handle because you'll have a lot of thrash in your system otherwise if it's constantly restarting processes. But you don't have to worry about what if I send a message to another machine in the cluster and I get back only half the response and nothing else. I can just restart the peer. That's fine, right? Or any number of the unknown unknowns. Thing that literally happens in these long-running systems, because they'll have Erlang running for like a single system 10 years without restarting it, right? That's a long time to have a server up. And what can literally happen is you can have a cosmic ray from space hit the platter on your server or a point in your RAM chip and flip a bit. And now things are broken. You don't want to have to guard against that. So you just let that process die and you restart it. In these high load, high concurrent systems, let's say we have a 1 in a million bug. That 1 in a million bugs happening every couple seconds, right? So you want to guard against that as much as you can, get to the 1 in a billion bug. But if you're running for this long, you'll also see that bug too. It has a really nice declarative configuration. People hear about supervisors and they get all scared because it's something they haven't encountered before, but they've made it really, really easy. It's this one line down here. So this is setting up a project. So this is a supervisor. And this init function, we're saying, here are the children of the supervisor, the ones that we're going to supervise and look after. They are, in this case, just one worker, but we could have other supervisors in there and a bunch of workers. And when they fail, if one dies, then we have a restart strategy here called one for one. And there's a couple of these that we're going to look at next. You can also write your own, but for the most part, these are tried and true and just kind of work for most cases. So we have a few strategies. These are the 4 main ones. one for one, simple one for one for all, and rest for one. We're going to skip simple one for one because it really just says these are all the same worker, just make a whole bunch of them, and if one of them fails, just restart it. The rest of them look like this. So one for one says if one dies, the virtual machine will send a signal back to the supervisor that says, hey, something that you're supervising ended. And it will then look at its restart strategy and restart that exact thing with its initial code. It may lose messages, right? If it has things in the mailbox is also gone. So if it are things that have to exist and it's mission critical, then you have to stick them somewhere else or do replication or stick them in a database or something. But for the most part, this actually works really, really well and is the most common one that people use. Next one is one for all. So you have a number of actors that are working together doing something like the War and Peace word counter. It says that if any one of these fails, we need to restart the whole thing. So we get that signal back that it exited, we destroy all of them and reset the whole system. And finally, rest for one. This is mostly used when you're doing pipelining of data, is if one fails partway through the pipeline, you don't need to restart the first one, you just need to restart the rest of them in the sequence and then bring them all back online. And then they can start taking messages again from in this case, worker one. And just briefly touching on Phoenix, this is the Rails-like web framework for Elixir. Phoenix, because it's automatically has all those supervisors set up for you. You can supervise other stuff too, but the main web server does not go down, right? Everything's supervised. Your database connection, like the connection pool, also supervised. So your database isn't going to go down, or at least not for any perceptible amount of time. As we'll see in a second, it's fast, concurrent, and feels very modern as well. It's almost like a cleaned up Rails is sort of was their intention. So major strengths, you get all of the same goodness from the ecosystem, which is called the Open Telecom Platform, OTP. You no longer need an external queuing system like Sidekick or RabbitMQ. RabbitMQ, in fact, is the same system, right? So you can do all of this stuff directly in Phoenix. It feels very familiar. It has this Rails-like API or Express or any of those systems. Feels similar to that, but with a couple of things broken out in addition, and it makes it just feel very easy to test and modern. And because it's a functional language, for the most part, everything's being handed around explicitly. So you don't have to worry about doing all of this massive setup before you run your tests. You can just test the functions and get inputs to outputs, right? And instead of it being a big monolithic system like Rails, it's a bunch of libraries that are stuck together. So if you don't like the way that they're doing the database DSL, you can stick a different one in if you really want to. You don't want to use JSON, which is what it comes with out of the box. You can stick GraphQL in there and everything will work just fine. It defines some really standard, nice interfaces to have all those things hook into it, and everything's fairly well, especially for Phoenix. Everything has an adapter for Phoenix now, which is nice. So it's very, very opinionated. It has some safe defaults, and there's primarily a focus on developer experience, just like Elixir in general, sockets and performance, and of course fault tolerance, because you don't want your web server going down. You want the add to cart button to fail for one person, not for everyone, and then for the process to restart. You can also, since sockets are in there, it has first class support for sockets, both on the back end and the front end. It'll generate a front end helper module in JavaScript for you to deploy. And if that socket connection goes down, it'll restart the connection live and reconnect to the client for you. Here's what an example request looks like, just printed out in the logs, right? So this is just getting the root on the page controller index. And there's something kind of odd in there. It says microseconds, not milliseconds. It has this little mu symbol, which is great. It's very, very, very fast, right? So this is running in 0.2 milliseconds for serving an entire web page, which is not bad. Of course, this is locally, no lag, but it's not bad. As I said before, it has a similar structure to Rails. This is the tree, but I kind of expanded that out a little bit so you could actually see it. We have our main application, and this one's just called To-Do. This is an app I used when I was still teaching Elixir to companies. To-Do app, right? So To-Do is the actual application itself, all of the models, all of the, the main core business logic. And then To-Do Web is all of the web stuff inside. So we have sockets, channels, a router, controllers, templates, views. So if you have a Rails background, what are called views there have been split out into the data wrangling parts and actually sticking it into a web page. So you can use a view directly as JSON or stick it in a web page. And then that bottom one, todo.ex, .ex is the extension, is the setup for the main project, the supervisor, and all of that too. And of course, it has generators for code and all of that built in as well. Here's what a controller looks like. So we have a module and a function for show, create, update, and delete, CRUD actions. We take a connection, and index at the top there. The app spec directive there is the types. So we don't have strong types like you would find in TypeScript, but we have something close there. You can still lie to the type system, unfortunately, and it's something that they're experimenting with. I'm not totally sold that Elixir needs a type system. Anyway, you take the connection, which is the whole, here's the actual request and the user that this needs to go back out to and all of that stuff, and the arguments in. So these could be both params or from the router in a certain part of the path. So for show, we get the ID, we take the user, we get it out of the repo, which is the database. We preload its lists and completed items, so the related models, and then render it out as JSON using the template show.json. Same thing with create, this user.change set. There's essentially a validation pass that is required, it's enforced. Update, very similar to the create, and delete, remove something from the database and respond with a 204, right? Further reading, because I guess this is on video, we can throw up a list of links. So there's a bunch of books that I haven't listed here. They do mention some on elixir-lang.org. I also have a Medium article from a few years ago, so it might be a little out of date, called Up and Running with Elixir and Phoenix. Things to dive into first are IEX and Mix, that's the REPL and the build tool. GenServer, which does all of the different kinds of actors that you can build. It's, battle tested, 33 years old now library that works really, really well. Broadway is new. It is from the core team to do really heavy concurrent pipelines with incremental backoff and load balancing and all this stuff, but in a declarative way. So you don't have to go and actually program that out. You just say, here's what the structure would look like, build that for me, and it'll go and build the distributed system. And Phoenix Live View, where it's not a totally new concept. Some other systems have done this too, but they just added this in a couple months ago now, I guess, where you just write a regular backend web page And when it serves it up, it includes JavaScript for all of the dynamic parts of the page, and sets up sockets and all of that. And people can click on a counter and it can increment in the database. And it does all that wiring up for you, so you don't have to write it by hand, which is quite nice. So it works for a lot of cases. Someone went and, don't do this, but somebody went and wrote Flappy Bird with this style, which is a lot of events, as you can imagine, going over the wire. But they were able to do it live on stage with a number of people like playing from the audience. So it works, it's pretty good. Some of these other ones on here, the Platforma Tech blog, that's the company that does most of the R&D into Elixir. They have some really nice articles. The two repos that I used to use when teaching, Uprun and To Do Example and Quick Chat, are all available. They're open source. Quick Chat's interesting when I have people doing a day course or a week course typically. I would get everyone together, install Elixir, download the repo, and then set up a totally peer-to-peer Gossip Protocol chat app in the terminal. And then we'd spend the rest of the day building it, because that's the sort of thing you can do after one day of Elixir, which is pretty cool. And on Twitter, if you look for my Elixir status, you'll get all the stuff people are working on Elixir. Thank you. If anyone ever has questions, I'm always available at that email. I'm XSpeed everywhere on the internet. Tweet at me, DM, etc. Open issues on repos. Always happy to chat.
Thanks.
That was awesome. Thank you.
Do we have any questions? Edu, I feel like you do.
Yes, I do.
Excellent.
Like main questions are not that many about the ecosystem and the work. I would say my main questions to you would be how would you recommend testing the waters with Elixir or with a new language like Elixir in a product company like Buffer?
So I think it really depends on the needs, right? Adding more languages is not always the right choice. So even though I'm giving this talk about this interesting language and all the concepts it brings and all of that, you definitely see, especially as microservices have been getting more and more popular, people adding more and more languages. And now you need to have people that understand 5, 6, 7, 8 languages, which is great for a few people, right? It scratches that itch, but it's not great for everyone. And what you don't want is to get into a place where people are having a bad experience with any language and then taking that everywhere else they go and saying, never use it. We used it and it was a disaster because now we had 15 languages in our system, right? Good places to use it, if you were to go that way. I typically see it in Ruby, Node, and Python projects to do sockets as a first app. So you need something to be a little bit more concurrent, more real time, a chat server, that sort of thing. You still serve everything off of the, let's say, Rails API, but it can talk to the chat server that's doing all the sockets for the user. And I've seen that a bunch of times. And a really nice use case for it. It really fits the design space well.
Cool. I'm gonna let some other people ask questions. They can jump back at
question. Would it make sense to start with like Phoenix? Like if you have no experience with Elixir at all, like is Phoenix a good entry point, or is there more like stuff you should learn before?
So you absolutely can jump in with Phoenix directly. You're probably familiar with how it's set up, right? It may be a lot of libraries to learn out of the gate. A lot of syntax, there's a lot of DSLs in Elixir, partly because of the meta programming, but even without that, right? It's like, well, how do I set up a database table, right? Which might not be the first thing that you want to learn in a language. I would say work through the Elixir Lang website tutorials first. Maybe do like, I don't know, what's a good example? Build a calculator, that sort of thing first, right? Build like a really small project, and then dive in. But as a first sort of like, let's build an app that actually does a thing. Yeah, absolutely. Phoenix is great. There's lots of tutorials, lots of information. You can deploy to Heroku with a build pack, but there's tutorials on that too. It's a very friendly ecosystem. And the other nice thing that they brought over from Ruby is it's a very friendly group of people. So both the core contributors and everyone else. In Ruby, they say Mats is nice, so we are nice, and we say Jose is nice, so we are nice, right? So it's a nice group of people that are very, very willing to help. And a lot of people are very, very passionate about it. So even, putting your hand up on Twitter or what's the forum called? I think it's Elixir Chat or something like that. People are always more than happy to lend a hand. Or you can always email me.
Awesome. Thank you. That's super awesome. I have one more question. If no one else.
Okay.
How's the memory footprint? Like I sometimes have a little Raspberry Pi that I've put like a node server on for a little personal home project, smart home. It's a little slow because it's a strapped device. So I'm wondering, like, is this something that I could potentially like put onto a lower memory, lower power device, and it would be more performant? Or
Yeah. So it will work on Raspberry Pi, absolutely. It's designed in a lot of cases for hardware like that. Like people will set up racks of Raspberry Pis and network them as a little cluster and do that. You can. If you're interested in that kind of thing, you should definitely look at Nerves, which is both for Arduinos, but definitely for Raspberry Pis for sure. And you can do hardware programming on that. So one of the two main guys behind that project has done a bunch of stuff. He's wired it up to his motorcycle to do an auto starter from inside from his phone, or lights on the back of his jacket. So it'll have like a turn signal on the back of his jacket. It pushes updates over the air if you have it Wi-Fi enabled. So you make a change and off it goes. You literally just plug it in, flash the drive, and you're good to go, which is great.
Awesome. That's so cool. Thank you.
I have one more question then, if nobody goes. Brooklyn, you mentioned before that you were training developers in companies to work with Elixir. Mm-hmm. So in your experience, like when a company finds a need to use Elixir at some point, how long would you say that takes for developers to be productive? So how is the learning curve for it once you are committed?
Yeah. So when teaching, we get people productive building production apps in under a week. It's familiar enough that it's not, you're not rewriting things relearning things totally from scratch, right? Typically web programmers, right? So it's like, here's the equivalent in, whatever language that they're coming from. Here's the equivalent in Node. Here's the equivalent in Phoenix, right? For people doing this on their own in a company, I have less direct knowledge of that because I'm usually brought in as the expert to teach people. Both, like I've been hired to do that sort of, full-time or brought in as a consultant. I'm not usually coming into companies where it's like, oh, so-and-so is off in the corner typing in Elixir and we need to get everybody else up to speed. It's, we have some pain and we think this is a good fit for us. Can we do this? So anecdotally from talking to people, it sounds like it's, without any help, it's, you can be up and running fairly quickly. You're just not as productive at first for a couple of weeks. And then people settle in pretty quickly and often find that they're, because it's a newer system, right? It doesn't have all the cruft. They're often more productive after a couple weeks than they were prior. That also might be a bit of second system syndrome as well, right? So it's hard to say, but the short answer is with actual guided direction and somebody to ask questions to, it's like 3-4 days and you're writing production ads.
Cool. Can you explain second system syndrome?
Sure. Yeah, so there's sort of two sides to it, and that's we're going to rewrite everything, right? So people have a list in their head of everything that's broken. They've already spent a bunch of time in discovery, right? Most of the time that we spend programming is in the discovery phase. And then when you rewrite it, that was so much easier in this language. I mean, maybe, but also you already know the problem space, right? Second system syndrome is especially, we're going to make everything perfect this time. And we're going to add one of these and one of these and one of these, and we won't have this problem, we won't have that problem. And it's both of this like, light at the end of the tunnel and a tendency towards over-design early on. And, we're going to throw everything in the kitchen sink as opposed to we're going to do like an incremental takeover.
And are there in the language any, this is my last question. Are there in the language or in the tooling any reasons or any causes for better developer productivity in any way? Like, is it easier or harder to shoot yourself in the foot?
I see.
And whether like, the kind of libraries or the kind of ecosystem or the kind of documentation, whether it makes things easier or harder.
Yeah. So it has probably the best docs that I've seen in any ecosystem. They're really focused on developer experience, testing, great REPL experience. The web docs are honestly very pretty, very searchable. Like they have a really nice search function built in. You have doc tests, so you can make your documentation testable. So if you have any code snippets in there, you can run them as tests. The REPL experience, you can update, even live, update your module and have it just available in the REPL, which is nice just with a reload. And because it's a functional language, you're typically just, again, inputs to outputs, right? So you're not worried about like, oh, I had all this stuff set up and then I restarted the REPL and now everything's broken, right? You do a lot of REPL-driven development because you can just say, take these inputs, stick them in a variable and just run that again and again as you're working. Ways to shoot yourself in the foots. Macros are a great way to shoot yourself in the foots. When teaching the course and we get to the macro section, I say that there are 2 rules of Macro Club. Don't use macros and don't use macros, right? And I say this as one of the people who's probably written the most macros of anyone, like literally anyone. They are extremely powerful. So it's, as your code's compiling, it does 2 phases, right? It literally just breaks down the syntax into a tree, and then you do the macro pass. And they are compile time functions that take in literally the AST, like just the syntax tree, and transform them into something else. So you can have all kinds of dark magic happening in there, right? In the ideal case, you're using that to build new syntax or a feature that you want, but people can go very, very far and auto-generate entire apps, at compile time from a declarative spec, right? Like you can go way, way too far and really shoot yourself in the foot, and just make it too much magic. And it's hard to read because now you're working with raw AST rather than the code. And, so that's a common thing. People discover this and go wild with it. The other one to watch out for is because it kind of looks like Ruby. If you have a Ruby background, people expect it to behave like Ruby. It's not Ruby. It kind of sort of ish looks like Ruby.
Great. Thank you so much.
Yeah.
Shar, did you have a question?
No, just giving thumbs up. Thank you so much for all the great explanations. This has been a really great chat. I appreciate it.
Awesome, thanks.
Yay. Does anyone else have any questions? They don't necessarily have to be like just Elixir questions. They could also be any of the general concepts that Brooke touched on in her talk. Okay, I kind of have one. Brooke, how exactly would you do a progressive takeover of something like Elixir, which is functional, if one were to be in a non-functional code base? Like you touched on that, and you have 2 minutes.
Okay. Progressive takeover of a non-Elixir app. So
yeah.
with
Please no one do this, by the way, just hypothetically.
So I think it's less the language family and more adding another language into the ecosystem, right? If you don't have direct interoperability, it doesn't really matter, right? So pushing the problem that
Brooke, can you clarify direct interoperability? I'm not sure everyone knows what that is.
Okay. So TypeScript and JavaScript can interoperate directly. Erlang and Elixir can talk to each other directly. Java, Scala, Clojure, Kotlin can all talk directly, right? Ruby and JavaScript, you can't do that. You have to push things over some serialized formats. My AirPods are continuing to get me. Can everyone still hear me? Yes, okay, great. So to do the problem that you have fundamentally in all of these cases is state, right? Not the functionality. So rewrite a module, right? Or some functionality. Cool, great, that lives over here, but you need to get the state across somehow. So there's 2 ways. One, you write a wrapper around the boundary of the thing that you're trying to rewrite, and you slowly make that boundary smaller. So you stick it over the wire more and more. Or you start pushing your state out into some third system, RabbitMQ, Sidekick, a database, something like that, and then let that get shared between the two. When people are doing these socket systems, like a Rails code base with a pure Elixir, like not even Phoenix, just an Elixir socket server, usually they're passing that back and forth over HTTP, or I have seen it done directly in system pipes, which you can also do.
Cool, thanks for explaining. Are there any last questions or thoughts? Feel free to unmute yourself. Cool. Alrighty, well, thank you so much. Brooke, that was really great. And we will share the recording and the slides for everybody watching. And you can find Brooke at XSpeed on the internet, and her email is also in the slides. And yeah, Brooke, thank you so much for taking the time to give this talk and to prepare for it. People have been really interested and excited about learning about Elixir and how you think about these things in general. So thanks a lot. We appreciate it.
Awesome. Well, thank you so much for having me.
Great.
Thank you, Brooklyn.
It was awesome. Thank you so much.
Thank you.
Thanks. Cool. Okay. Bye, everyone. Have a great day. Cheers.
Bye-bye.